All right, good afternoon, everybody. My name is Dave Stavaker, and I'm a Chief Platform Engineer at Direct Supply in Milwaukee, Wisconsin. And I'm also an AWS hero. Earlier this year, we wrapped up a project migrating a corporate monolith file server with about 20 terabytes of data using AWS Data Sync over to Amazon FSx for Windows file server. Our data is kind of unique and extremely problematic. And so I want to talk to you today about some of the things that my team and I had to do to automate our way through this migration. There we go. All right, so we'll cover a little bit about me and the background on this data. We'll talk a little bit about our journey to the cloud and why our data is the way it is and was sitting where it was. We'll talk about some of the ideas we had going into the project, and that'll set the stage for some of the big missteps that we had early on. And then we'll talk about the tools that we built to be able to kind of wrangle our migration process and get it down. Our end goal was that we were able to deliver an entire 20 terabyte migration with just 2 hours of downtime to the business. So we'll go through all of the tools we built, all the process we applied, and some of the lessons learned at the end. I'm also hoping to leave time at the end for questions. So if you do think of any good questions you want to throw my way, we'll leave some time at the end for that. All right, so a little bit about me. I started working at Direct Supply 22 years ago, founding their first real help desk environment, and quickly moved into the sysadmin world and found that I had a real knack for managing storage and data protection. So for the last 20 years or so, that has been my area of focus and specialization. In 2003, I deployed my first SAN, a whopping 4 terabytes. And when we finally started our move to the cloud in 2016, we had grown to 1.2 petabytes of spinning disk. So if you do the math, that's about a 30,000% growth over 13 years. So lots of data to manage, lots of storage to manage, lots of experience with things breaking and having to fix them, recover them, manage them. Like I said, we started experimenting in AWS in 2016 and started our formal migration in 2017, leading up to moving 95% of our enterprise into AWS in a single 8-hour window in mid-2019. I was invited into the AWS Heroes program in 2019. And if you're curious about that, I'd love to talk about it, but maybe offline after the session. And this is my 7th reInvent and my 2nd time presenting on storage stuff at reInvent. Okay, so I mentioned that we moved 95% of our infrastructure into AWS on a single day in 2019. And we have this corporate monolith file server that we knew had to travel with all of our applications. Running it on-prem on a NAS device in our data center gave us too much latency for some very time-sensitive applications that were being moved out to the cloud. So we had to move the data with the applications. And along with that, half of our end-user compute stack moved out into workspaces as well. In 2019, there were not a lot of options for Windows-based file storage in the cloud. The top 3 were that you could build it yourself on Windows and cluster the servers, add your own EBS volumes, and it's a high-touch, high-management environment that guarantees failovers and downtime when your monthly patching cycle comes along. The second option was a marketplace solution that was built on top of S3. So it would create a bunch of empty objects in S3 and then stripe across those for your file system. We test drove it. It was an interesting idea, but it just didn't meet with our needs. The third solution was what we ended up going with, and it was a marketplace solution from a popular storage reputation company. And the idea for their high availability was that you had a compute node in 2 AZs. You presented a bunch of EBS to it, and it would layer its RAID across those EBS volumes. And then you had a third node in the middle that acted as a witness. And if anything went offline or it lost connection to one of the 2 storage nodes, it would update a route table to point a floating IP address at an ENI attached to either one of those 2 storage nodes. It was the best option that we had at the time, but the updating of the route table only worked inside the VPC where the storage lived. So our on-prem users didn't get that update published to the route tables on-prem. Things in other accounts, other VPCs also didn't get those updates. So if we had a failover event, only a small portion of our environment would follow with it. But we could manually make those changes, we could update DNS, we could get things running. And of the three options, it was by far the least friction to get our data into the cloud. Now, a little bit about our data. We're a healthcare equipment company, and so we have some sensitive data that flows in and out of our system. We do some e-commerce, so there's some PCI stuff. We sell medical equipment, and though we don't handle HIPAA data intentionally, sometimes a patient name can end up associated with a piece of equipment that would identify a concern they have, and that needs to be handled just like any other HIPAA data. So we don't seek it out, but we sometimes inadvertently end up with it in our systems. So we have to be very careful about how we store and manage the data. So we needed things like encryption at rest, encryption in flight. We needed to be able to audit all of our access logs and get that data into our SIM so that we could make sure that we had the appropriate file interactions happening on a regular basis. We also needed the multi-AZ high availability story, and we needed a good way to back it up. And really our desire was to have that integrate with Windows VSS so that our end users could restore their own files when they needed to, and that we'd still have a full system recovery for disaster recovery. So this solution gave us those pieces. It wasn't 100% perfect. It has improved over time. But we knew going into this that FSx for Windows was in development and that their product roadmaps were going to support what we needed. So this was, going into it, this was a known temporary solution, and it was the best option that we had in 2019. Now, a little bit more about our data. We have, in 2019 when we moved, we had about 14 terabytes of data, and that's about 1 billion files. And it's broken down into two big buckets. About 20% of the data, if you're looking at it by volume, is Office documents, user-generated content. The rest of it is tied to our internal applications, our order processing systems, our websites, our e-commerce, all of that relies on this file server. So great, it's 1 billion files, no big deal. Well, in the 4 years we're in the cloud, that grew by 50%. So now we're 20 terabytes and we are 1.5 billion files. But here's where this gets really sticky. If you look at the number of files in each category, the end user generated content is really only about 2% of the total number of files that we had to move. So that means of that 1.5 billion files, the majority of those files were living in tiny, tiny little application-generated files. Most of them were very small, like a bunch sub 1K files. So when we talk about data migration, there's really a couple ways you can migrate data to a new file system. If you can get access to the block level data with a tool that supports it, you can copy that data at the block level. And that's great. It doesn't have to interact with the file system. So it doesn't care if you have 1.5 billion files or 15 files. It just grabs the blocks that have changed and keeps those in sync. But when you're going for dissimilar file systems, you have to interact with the file system and do a file level copy of that data. And so what this means is that when you have to figure out what's changed to keep it in sync, you have to comb through 1.5 billion tiny little files to figure out what's changed and what's unique. So this proved to be very challenging for our migration. Okay. Oop. There we go. Okay, so in April of 2018, we knew about FSx. I'd mentioned that. We were one of the first private beta customers in the FSx program, and we started playing with it and saw a lot of promise. And it developed over time to meet the features that we needed in a file system. So this is just a brief timeline of kind of how FSX for Windows has developed here. So things like June of 2019, we got Active Directory integration. That's great. We're a primarily Windows shop, at least where this file system is concerned. And so we needed that Active Directory integration. February 2020, we knew data sync was coming, and that came online. And the thing about data sync is it's very efficient over the wire, and it integrates directly in the AWS console with things like CloudWatch. So we didn't have to have a bunch of robocopy scripts that spit out every single file name that they've copied and have to go scavenging those looking for problems and errors. The data sync console and the data sync product does a much better job of helping us with some of those error handling. Okay, June of 2020, this may come as a shock, but June of 2020 was when they added capacity scaling so that you could online grow your file system and increase the throughput. DNS aliasing came along later in 2020, and that was critical because we have thousands and thousands of references to this file system in our internal code base, and I can't even fathom the nightmare of pull requests that we would have gotten into if we had to rename this file system to something different. June of 2021, we got our file access audit logging, and in March of 2022, Private Link came on board. And that was really the set of core components that we needed for FSX to be ready to support our data and our use case. Oh, and one other thing in there. You'll see the Terraform logo in around the July-August timeframe of 2020. We are very, very focused on doing everything as infrastructure as code. The rights in our AWS accounts do not allow anything to be spun up through the console. It all has to go through an audited deployment pipeline to get into our space. So everything we do is built with Terraform. And it took Terraform a little while to support all the features that we needed to be able to get our file system even deployed in the first place. So this is why in 2019, we moved our data onto a temporary file server and waited until 2022 to come along and start our FSX migration. Okay, a little bit about the tools here, in case you're not familiar. AWS Data Sync is a file-level copy tool that can copy from many different sources to many different sources. So things like EFS, EBS, S3, and FSX. So you define a source location and a destination location, and you give it things like a schedule, name the task, and you spin that up. You can set some throttling on it if you want to. And those parameters create what's called a data sync task. And that task is the definition of your copy job. Now you associate that with a data sync agent, which is essentially an EC2 instance running a proprietary AMI. And that's the compute resources behind your data sync copy job. So we built Terraform to handle all this data sync stuff. We'll go into a little bit of that in a minute. The second piece is FSX, and this is a managed service. So when you deploy your file system, you're really just telling it how much space you want, what availability zones you want it in, and how much throughput you want for your cluster, and then give it a domain name and some credentials to join. And that will get you a file system running in AWS. Now there's two types of storage supported. There's solid state disk, and then there's spinning disk. And the thing is, spinning disk is fantastically less expensive than the solid state disk, especially when you're talking about a multi-AZ deployment, because you have 2 copies of every file. So we had a situation come up last year where we wanted to fund some new initiatives. And so our FinOps guy said, hey, what can we do to dial down our spend? This file system we're running seems to be a really good cost that we could maybe target. So we did the math, and we were very aspirational about what we could deliver if we ran this project. So if we could get to spinning disk at a very low 32 megabytes per second, we could end up delivering a massive savings. Our monthly run rate on our self-managed NAS was $35,000 a month. we could get it down with FSX on spinning disk to like around $1,000 a month. That's huge. So we started off as a cost play. And the reason that's important to call out is that all the decisions we made up front were made with cost taking priority over time to copy the data or the impact of copying the data as far as downtime goes. So just keep that in the back of your head as we're talking through some of this stuff. Okay, so the first thing we had to automate is our Terraform. We had to have it in code so that we could deploy it through an audited pipeline. So where FSX is concerned, we passed in all of those parameters that we already talked about. And not listed here in the list, but certainly also included, is that we automated the integration with file access audit logging in our SIM. So all of that happened as well when we stood up the file system. And we stood it up, like I said, first time through on spinning disk. The second piece is we built a module to handle all of the data sync bits. And the one thing that I think we did really well here is that because we had a source location and a destination location, and that was creating our task to move over to FSX, we had all the information we needed to swap that and build out rollback tasks if our migration had to be rolled back for any reason. And they were just sitting there waiting in case we had an emergency and had to roll back for whatever reason. So through the automation, we were able to build our rollback plan with really no extra effort on our part. So we got our tasks out there, we got our file system ready to go, and then I opened my mouth and said some things that were very bold and that I would highly recommend you not say when you're planning a file system migration, especially if you have complicated data. So we went into this very cavalier, thinking this is going to be easy, and it's going to be just a few weeks, and that, hey, it's cloud, infinite scalability, we're going to be great. The truth is, it took a lot longer than a few weeks, about 11 months, to finally get everything dialed in and to get us there. And I want to talk about that roadmap a little bit. So we started out with 4 agents and 8 data sync tasks. Now you might be thinking, like, what is this guy thinking? You've got 1.5 billion files out there, 8 tasks, you're crazy, that's going to take forever. But we needed a starting point, and again, cost was front of mind. So we didn't want to spin up dozens of agents and be saturating a high bandwidth file system. We wanted to see how far we could push the solid state file system. And the answer is we could push it all the way to maxed out and have it fall over because we had way too much data to push to the file system, and the file system couldn't keep up. So we were bottlenecked. We had some tasks that were taking like weeks and weeks to run just the first initial full copy. So it was a starting point, but we had to start scaling up and scaling up. And if you've ever worked with Terraform, you know that when you run a Terraform plan command, it will spit out all the details of everything that you're updating and changing and manipulating. And when it was just 4 agents and 8 tasks, that wasn't a whole lot to manage. But as we were scaling this up and up, adding more agents, adding more tasks, it became unwieldy. We ended up with 150 data sync tasks and more than 50 data sync agents to manage copying this data. So the first tool that we built after the Terraform was a parser for all of this Terraform output data so that we could go into it and know that, like, okay, we're making a small change here, but we still have to sort through 2,000 lines of output, maybe more, just to figure out what we're changing. And we needed a way that we could go into it knowing that when we hit deploy, it was going to be a safe change and wasn't going to like undo weeks of work. So a few lines of code here, just parsing through that, gave us an idea that, gave us the confidence that we needed that when we hit deploy, we were safe to roll forward with that deployment. Now I mentioned we scaled up, and we scaled up to 150 tasks. And if you look at the data sync console, the output is paginated when you go to look at your task run history. Now we have some tasks that were running for 5-10 minutes, and they would repeat on a frequent schedule, every hour, every 2 hours. We had some tasks that were taking multiple days to run and complete. And when you've got a dashboard in the console that only shows the last run, the last 10 tasks that have run, it's very easy to lose errors and to lose job completion status in this massive output. In the space of our longest task running, we could have had 500 or 600 task executions in there that were getting lost in the debris of the data. So the next tool we built was a tool that would give us reliable runtime tracking. So every time a task kicked off, it's got logs that are written. We could query the data sync API and have it return the last 2 results. We could have it return the last 5 results if we wanted to. But we took this opportunity, since all the data is there and you can hit it through the API, we took the opportunity then to track not only success or failure, but what agent those tasks were running on and how long it took for that task to run and complete. And what this gave us was a really nice Excel spreadsheet that gave us all of that data in one easy to spot place. So I could look here and see okay, my fax job is taking 5 minutes to complete. That's great. I don't have to worry about my fax job. And my calls job is probably, we're at 8 hours. I might want to do something about that, maybe apply a little more resource to it. And certainly that archive task at the bottom at 26,345 minutes to complete is not going to work well with our goal of getting this done with only 2 hours of downtime. So we had to start using this data so that we could understand how we can get better use of our data, better use of our bandwidth, and better use of all of these tasks and agents. So the thing with data sync is you can add multiple agents to run one task, or you can run multiple tasks on any one agent. So having all of this data in a consolidated place where it shows you if you're successful or not with these tasks gave us the data we needed to be able to maximize our resource usage. Next thing we needed was a dashboard in CloudWatch that would give us an idea of how our file system was performing so that we could look and see where we were maxing out resources and where we were not using any resources. So you can see there's some dead space in here, some very low utilization, and that became time windows to really ramp up running other tasks in parallel. So we were able to start with an idea of what we were using and what we weren't using, and really hammer into that to make our runtime more efficient. Okay, so we kept throwing resources at the problem, and when we first started, like I said, we were on spinning disk. We had 4 agents, we had 8 tasks. We grew that up to 50 agents and 150 tasks. This, combined with maximizing all of our resource utilization, took us from an average of 96 hours to complete an incremental task or an incremental copy on each of our tasks, down to 16 hours for all of those tasks. So at that point we thought, okay, this is pretty good. We're kind of hitting a point of diminishing returns. If we keep throwing resources at it, eventually we're going to max out. We've hit a performance point where maybe we could find a way to do this, doing the most critical stuff during a downtime, letting the less critical stuff trickle in after. So we took the data and we said, look, we've got a good plan, we've got a good time for doing this. And we said, here are some calendar dates that would work for us to be able to pull off this migration. And the business came back and said, that's great. Here's the date we want you to do it because we have conflicts on the other dates. You're going to interfere with customer events or other big high-profile changes. So they gave us our date, and the teammate that had been working directly with me on this project said, ooh, sorry, that's the one Saturday I can't do it. Going to be out of town. So that kind of took our well-organized plan and threw it back into a little bit of chaos. So we had to make some order out of that chaos and kind of get our hands around how we're going to migrate this data in a short amount of time. So I put the NASA logo up here, and I want to talk about that first. I grew up in the era of the space shuttle, and I was fortunate enough to have a day off the day that NASA launched their final shuttle mission. and I fired up NASA TV and I watched the entire launch, like the 8-hour sequence leading up to when the rockets ignite. And the thing that really struck me with watching that is how well they planned and executed that launch. Everybody knows their task. Every task is timed out. When there are tasks that have a risk of failure or a risk of needing a little extra time, they build in buffer time into their plan. They have a clear definition of what will cause them to abort a launch and who can make that call and under what conditions they will make that call. So I took a page out of their playbook and started thinking about how we're going to migrate this data. So we have all of the runtime information. Data sync is running well. We've got our agent thing figured out. We've got our agent to task ratio worked out. Our schedules are good. So the next step was to prioritize our data and figure out, okay, there's business critical stuff here. We have to get this copied in a short amount of time. So can we copy our data with a 2-hour outage and then take the archive stuff from 7-8 months ago? Probably doesn't need to be online by 2 o'clock in the morning on a Saturday. That might be able to wait till 9 a.m. or 10 a.m., right? But the stuff that's gonna trigger delivering an order to our customers, when our customers are nursing home and long-term care facilities, you kind of can't mess around with that. So we prioritized the data to make sure that the most critical stuff would be copied and online within our 2-hour maintenance window. So then we used our timing and we used our agent connectivity and all of the mapping that we did to figure out the groups of tasks that we could run at any given, in that maintenance window to make sure that that critical data finished in 2 hours. And then, because there were 150 plus tasks, we needed a way to automate the execution of all those tasks and the validation and perhaps even a rollback of those tasks. So we bundled the tasks up into just text files, groups of tasks. Some had 4 or 5 tasks in it, some had 20, depending on their criticality and how fast they would run. And then we had a script that would process a text file. So you run, migrate group 1, go. And it would grab each of those tasks in group 1 and kick them off and get them running. And then once those tasks were done, we had a validation step that would return to us a very concise list of, have we succeeded? Were there errors? Do we need to look into it? And then rinse and repeat for each of the groups of tasks that we had. And this worked. This worked great. And because we had these tasks grouped and prioritized, it made a rollout script possible, it made a rollback script possible, and it made the validation a piece of cake. All right, so let me get to our night of, or day of, I guess. And about 16 hours before our migration, we scaled up the throughput on the cluster to the maximum. So at the time, that was 2 gigabytes a second. Earlier this summer on storage day, AWS announced that that now goes to 12 gigabytes per second. So you could probably do this a lot faster than we were able to, even just a few months ago. Now, 12 hours before our migration, we kicked off those most critical jobs again. So that way, our changed window for the data was less than 12 hours. And we knew those would finish in about 2 hours' time. And it was a good opportunity for us to validate that nothing had changed or gone wrong between our dress rehearsal and our final migration night. All right, 2 hours before we started the migration, we stopped all of our running tasks. And we had a whole automation built around this. So we backed up all the task schedules to a CSV file, and we had a process built ready to go that could restore those schedules to all of the tasks if and when we needed to. Then we went through and zeroed out the schedule on each of our tasks, so nothing would kick off after we stopped everything that was running. Then we targeted our queued tasks and turned those off, and then we went for the active running tasks. And it's important to do the queued tasks first, so you don't end up playing whack-a-mole with one task stopping and the next one in queue starting up. Okay, then an hour before, we manipulated a setting on a lot of these tasks that's called enable preserve deleted files. So the idea here is you have data at the source, you want the destination to mirror it. So if I delete something On my old NAS, I want that deletion to show up at the new NAS, as long as the NAS is offline and not taking in new data. But the minute we go live on the new NAS and that older archival data is trickling over, the old NAS is going to see that there could be new data, or the data sync will see, rather, that there could be new data at the new location. And so we didn't want to have any data loss. So this was critical. We knew when we'd be in the maintenance window, when we'd come out of the maintenance window. And so we were able to update all of the tasks that happened after our maintenance window to make sure that we didn't accidentally lose new data. Then midnight rolls around and we start our change window. And this is what I talk about when we had a really detailed plan. And I'm sorry if it's a little small to read, but the key things here are kind of highlighted in yellow. So we started right at midnight in the first yellow stripe there, start change, line 7. We closed any open sessions that we had so that hopefully servers wouldn't be trying to access the old NAS device. And we removed it from DNS entirely. We'd already set the time to live down to 1 minute, like a year before for some other reason. So we knew the DNS entry was not going to be stuck out there for 2 or 4 days on some other host. And once we verified that we couldn't hit the file server, we went ahead and started the data transfer. So you can see here we ran scripts 1 and 2, or groups 1 and 2. And we had some notes in here that we couldn't start group 3 until group 2 was done, because we would have had agent contention. So that allowed us to make sure the resources we expected to be available for certain tasks were guaranteed available for those tasks, and we didn't step on our resources. All right, we roll through, we run the validation steps in here. As those last copy jobs are running, we start updating DNS and updating the SPNs in our Active Directory so that the file system would work with the old name. And we were online, handed it over to testing. And this is great. I mean, we got there right before 2 a.m., right on schedule. Now, our initial forecast was for about a 16-hour migration total. We ended up, outside of our maintenance window, we ran for an additional 12 hours. So we got it done in about 14 hours end to end. And this schedule here goes on and on and on. So we knew when groups 5 and 6 and 7 and 8 were going to finish. So we could get some sleep after testing was validated, and then knew we had to be up by 9 to run the next batch of validations, kick off the next set of tasks. Now, I could have automated this a little bit more with some sort of a task scheduler, but we wanted to have that human-in-the-loop situation where we weren't kicking anything off if there was a problem we had to address first. So in the end, we got all of our data moved over, but we learned a lot in the process. So the first thing that we learned was we should have disabled or altered the security group on the source NAS instead of just trying to close connections. Because some Windows servers in our environment cached their connections and were reestablishing connections after our migration had started. Now, we know all of our business processing stops at midnight and is completely dormant until 2 a.m. So we were comfortable knowing that we had not written new data to the old file system. But where this became a problem is that we then had to restart a bunch of those servers right outside the maintenance window. And that was quite disruptive. It took us a while to identify what was going on. Then we came up with a fix very quickly and were able to get things back up and running. But that was about an hour into our, of time outside of our migration window where we weren't 100% online processing data. The second thing is taking the least expensive path doesn't always save you money. So the minute you deploy a file system, you're paying for it. And if you're talking terabyte scale file system, you're paying for terabyte scale file system, whether you've migrated to it or not. And so when we started off really trying to get to a massive cost savings by using spinning disk, we wasted a lot of time, and that time translates into money. So having that mindset of we've got to manage costs, we've got to keep our costs as low as possible, kind of blinded us to we might need to throw some resources at this to get it done faster and then chase down the savings. All right, dashboards are critical. Have these early on. It took us a while to figure out where our bottlenecks were, where our hiccups were. And ultimately, we got the right tools built and the right tools deployed so that we could manage that. But go into it thinking about some of the tools that I've talked about here being important to your migration. And I'd be happy to share those with you. I'm happy to save you guys the time in any work that you might be doing with a file server migration. Next thing is knowing your data. I knew where the super tiny files were and how bad the sprawl was getting. But if you don't know that, you should start out before your migration with the discovery sprint and understand your data. Now, there are paid tools, there are open source tools that you can use to help you with this discovery. I mean, worst case scenario, you can always right-click on a folder and look at the properties and let that count. Maybe not 1.5 billion files, but that can give you some idea of how your data is mapped out across your file system. But knowing that is critical because then you can anticipate some of these long-running jobs and some of the complexity of interacting with the file system and get out ahead of that. Okay, this would not have been a successful migration if we didn't have the tool that we built to capture the reliable runtime information and the success failure status of every task execution. So if you take one thing away from today, grab that script. It'll be in the slide deck. I can give you a copy of it. Come see me. That is the single most important thing that we did to help get a handle around how we are orchestrating this enormous volume of tasks and agents. And then the last thing I want to talk about here is data deduplication. So our old NAS supported data dedupe and compression, and we were using it, and it was great. When you copy compressed and deduped data onto a new file system, that data gets rehydrated. And so if you look at your file system and say, oh, I have 7 terabytes of data, this is great, but it's compressed, you're not going to move on to a 7 terabyte file system just organically. So there's a few approaches you can take here. One, you can just expand your file system and assume that you're going to start with fully hydrated data, understanding that the free space you'll free up after deduplicating is going to just be residual free space that you'll use over time. The second approach is you can copy some data, deduplicate that data, and then copy some more data and deduplicate that data. We actually tried this. We tried to automate it, and what we were finding is that because of the complexity of the data and the billion plus files, the dedupe tasks were taking a lot of time, and that was really disruptive to actually being able to copy the data. And the goal wasn't a dedupe project, the goal was a migration project. So we had to kind of back off of deduplicating. The third thing you can do is just give up on dedupe and just move it to fully hydrated. Especially if you're hitting a spinning disk platform where you're paying pennies a gigabyte, that might not be that bad. Then you don't have the I/O and throughput disruption of deduplication tasks running, because those run post-process. So you copy the data, then it has to be compressed and deduped. So you're taking all of that I/O out of your file system and allows you to save on some of those resources. Every use case is going to be different. Do your own math up front. But you need to make sure you pay attention to dedupe. Otherwise, you'll run out of storage space halfway through your copies, or you'll end up with a lot more storage space than you anticipated. All right, so there's also some question here around probably how did things end up? So we started off at $35,000 a month, and we really wanted to get down to $1,000 a month on spinning disk. We know that our data, our normal access patterns on a day-to-day basis are going to be low. We know that spinning disk could work for us. It was the migration that prevented us from getting onto that spinning disk. So as of right now, we are still on solid state post-migration. We still managed to save $11,000 a month on our storage spend to hold this data. We experimented with doing a backup and restore to a spinning disk file system and running like a mini migration to get failed over. But that was ending up taking more than our maintenance windows would allow us to do. So we're kind of holding tight right now on the spinning disk. And our plan is that rather than trying to get this to, we're holding steady on solid state disk. Instead of trying to get to spinning disk, we're going to spend 2024 evaluating all of this data because I know there are better storage technologies to handle these billion little tiny files. Like S3 would be perfect for that. So maybe instead of investing in moving stuff from one Windows service to another, we invest in rewriting the tools so that they can integrate directly with S3. And we let S3 manage all the data, the lifecycle, the replication, all of that. Maybe we build a Lambda to zip up those tiny files and move it off to Glacier and just let it retire over there. But that's what 2024 is going to be, is trying to get from our current spend down to something a lot closer than our aspirational target when we first got into this. Thank you very much for coming, and I hope you have a great rest of your conference.